This is my video series on restoring an AKAI MPC 60 from 1988, a legendary drum machine loved by producers worldwide and known for its characteristic sound. In this video, I'm going to show the process of removing all of the circuit boards, finding some really filthy ones, and how I cleaned those up with isopropyl alcohol, and then finally testing the numerous electrolytic capacitors on the circuit boards to make sure they're still safe to use.
All right, remove this unused port here. This is DB25, RS232. The MPC 60 version one was planned for a future expansion like SCSI or whatever, but it just ended up not being implemented. As you can see there, solder flux on there. All right, so I was under the weather. I had a real cold, and I'm recovering now, but put this project on the shelf for a bit. So now I'm back at it. The plan is to take this board out, try to test some of these electrolytic capacitors and see if they're still safe to use. Electrolytic capacitors have a tendency to dry out over time, and then they can blow up if you put a lot of regular current through them. They can release their magic smoke, and that can cause other trouble for other components like ICs on the board. So I'm going to test those carefully before just casually powering this thing up. Now this cable is going to be a bit of a pain to disconnect. It's one of these clip things. That goes to the board below. This is a sort of unused parallel serial SCSI port thing. Kind of like on your old school IBM PCs. This kind of looks like a SCSI type connector, like a 50 pin. That goes to the board below. CPU board here, and then another huge SCSI type cable that connects to this board over here, which I think is the voice board. Don't quote me on that. Anyway, lots to look at. So I want to show what I've done here. This is not pretty, but this works. So I have very carefully put a little screwdriver into here. So I got this parallel with the circuit board, PCB, pushing that clip out. Now I should be able to slowly lift carefully, get that thing off there. See, so those are a bit of a pain. The next thing, we'll take this little ribbon cable off here. So that's going to this, I'm not sure what board that is. This looks like the echo loop audio out loop input, and then stereo, I think, stereo output here. This is audio output. Disconnect this ribbon cable here. This goes to that goes to the power board, I think. Source, power supply. That's disconnected from there. I've now loosened up this cable. So there's 1, 2, 3 screws. These go to posts, and I suspect they just connect down to the lower. So I'm going to try to loosen up these 3 screws. There are at least 2 screws holding the back panel. These are rusted, so a little bit of a fight. What I like to do is put the screws back in places they came from if I can. So then when I'm putting everything back, it's easier. So that's loosening up the board. Okay, that's loose. Oh. Okay, it looks like that screw just holds this bracket. Maybe. So the only other thing is to loosen these 2. There we go. Yep. Always be careful with Phillips. Stash that over there. This one. I always like to check. Looks like those screws are the same length. It's good
to know. All right, here we go. Free. Aha! All right, so this can be cleaned up now. That's great. Do some tests on those electrolytic capacitors. Let's see what we've uncovered. Somebody on Reddit helpfully told me about this whole situation here. They said this is the MIDI board, if I recall. And this guy is, I think that's a 3-volt battery. It's kind of like your old CMOS or BIOS battery on PCs that will remember the settings. And so this thing is surely long dead, so that can be replaced. And I think they told me it's soldered into place. So I can remove it. It looks hard to see, but EAT1, all right. Yeah, that is weird. The whole thing is a little disc that's suspended. I guess that is soldered. I thought it might have been a clip. All right, well, that can be fixed easily enough. I'm pretty sure. Something really funny I want to point out. There is a lithium with an N. I suspect that's a typo, but anyways, lithium battery explosion danger, qualified personnel and all that. There is what I suspect is the lithium battery. And the idea that there's an explosion danger is adorable. Now, in 1988, to be fair, maybe this was considered a little spicy, but these days in 2025, we've got devices like this, which are also lithium ion, capable of putting out to 1,000 amps in short order. They can start a car. Now, if you want to worry about explosions and spiciness, that's the kind of thing I would worry about these days. This is a drop in the bucket. When in doubt, compressed air. Try to dust this off carefully. About the underside of this board, I'm not an expert, but it looks like there's a little bit of bubbling or some kind of something going on there. And I don't know if that's solid or it looks to be like it's not moving, but it's not super clear what's happening. And if that's to be expected, if that was part of the original, how the PCB was made, overall, I'd say that's pretty tidy. Hopefully it's electrically solid too. All right, just an extreme close up on this board. This looks like some of that leftover flux, dirty gunk. So we'll get out the IPA and see what happens. Now, I'm assuming, it's not rust or some other kind of gunk. Looks like, that's working. It's just dirty. This looks like the same junk that was caked all over the other boards. There's less of it here, so you want to be careful about these connections, though. Go to town carefully on this. It's looking better than it was. Hard to see exactly what gunk is left on there, but that's better than before. Back on the top of the board. That's a decent example of the leftover solder, or rather leftover flux isopropyl. Just a little dab, and then that'll fix that up nicely. And you can get that gunk off with a little scrub from a Q-tip or similar. Not that this board piece particularly matters, it's the more or less unused. All right, fun with capacitors. These are the electrolytic capacitors. There are a handful on this board. This one's 25 volts, 10 microfarads. I'm gonna guess that a lot of these are the same value, which should be nice. I can apply the same rubric per se. Anyway, surveys in need. This allows measuring of capacitors' equivalent series, ESR, equivalent series resistance. Basically, you compare the number you get to a chart that tells you whether or not, worst case Ontario scenario, whether or not this capacitor is good and thus safe to use. So the first thing is we'll zero our leads so that they know nothing's connected. Should be close enough. 0.5, let's call it 0.59 ohms. 10, 5.3. So we're laughing. We're doing fantastic. So that is a good cap. This is a good sign because there are lots of these on this board. So I'm going to do a sanity check, and frankly, I'm going to test all the rest of these, and I'll add more video if there's any bad ones, but this is a very good sign. Cursory test, initial test of these caps. Everything looks good. I think these are fine, which is awesome because that means I don't have to recap. That is to take all these capacitors off and replace them. So that's excellent. I think this is the MIDI board. Yeah, MIDI out, MIDI in. Okay, those are all just connected there. Well, not all of our connections are loose. So the first thing is I'll take this thing off here. This one's fairly straightforward. This is similar to the other board. Just a couple of clips. So carefully clip comes out this way. This one comes out this way. And that whole assembly should just pop right out. There we go. Ta-da! So the nice thing is that should be, yeah, it's notched. Hope you can see that. So it only fits in one way. So that's nice. Next thing is these are the screws that were holding the top board in. I bet I can just take 1, 2, 3, 4 out, and then whatever, if anything else is holding the back plate. I don't think anything else is, no other screws back there, so I think it's just those 4. 1, 2, 3, 4. There's nothing holding that, the MIDI connectors on, best I can tell. Dollar store screwdriver. Does the job. Okay. Here. Just need it tight. So these do need to come loose. And that's slightly concerning because it looks like that's some sort of a ground and there are things attached to it. Shows okay. That goes to, and figure out how that connects to the bottom. So if this is a whole post, I'm guessing that screw's loose, but I really don't want to risk breaking the circuit board. TBD. I need to use this bit to get this loose. I do not like this. This has a connection to ground here. And so
I move that thing, I don't want to pull that little ring loose. Let's just see if I can move that safely. Okay, there it's going. But of course, it's moving that piece. Let's see. There we go. Okay, good. All right, so hold that, and then that'll move. Yeah, be careful. I don't want to move that too much, but there's your screw. Hold that. There we are. Okay. Yikes. Okay. Oh, and might want to mark this, but that's a fairly straightforward one. There. Thank you. There we go. Pretty clean. Some pretty wild custom wiring there. But other than that, nothing too wild to see. Ooh, what's that? Ooh, what? A little spicy. I wonder if a capacitor or something leaked there. That's interesting. Capacitor? No. Huh. Nighttime tech bench service. Well, anyways, we got the MIDI board out. Looks really overall pretty clean. There's some kind of deposit here that looks a little bit suspect. Better. Haven't hit this with air yet, so real quick here. Whoops. Easy, you don't want to freeze everything. I thought I'd have my work cut out for me in terms of capacitors, checking the electrolytic capacitors on this board. It's inaccurate to say capacitors, as in plural, because there's only a single electrolytic on this entire board. Now let's see if I can just, this might be dangerous, but we're going to pull it up and get a reading. 50 volts, 3.3 microfarads. That should be totally acceptable. Thank goodness. Just for now, I am going to leave that battery and get back to that later. I don't feel like doing any soldering tonight. Current state of operations, memory add-on here. This is the voice board underneath, I believe. I suspect all the caps on this are fine. All the caps, whatever might be on here is fine. And my guess is this machine will run just fine. But I want to take everything out and go over it with IPA and clean it up, just to be safe. All right, looks like 2 screws here holding the frame. One here, maybe a second. That, nope, that doesn't go all the way through, but that might hold, probably holds that bracket. There's a cable tie that I need to remove here. And then there's also a connector on this PCB that has a tab on it
These are kind of annoying, and I've shown this previously, but I use a thin screwdriver to help wedge the tab loose, and it makes it easier to disconnect. I also like to label these tabs for when I'm connecting them later. So this one is 402 based on a marking on the PCB.
This connector can come straight up carefully. And that has a notch. So that goes in on that side. And again, 302. So I'm just going to right on here. 302. Better safe than sorry. So that's free. Hooray. This one, it's interesting. This one has a whole board underneath it. Perhaps maybe because it's audio heavy, for noise or something. First thing, I guess, a little compressed air. Ta-da. Ooh, God. What a mess. Okay, this is very similar to the... Wow. Glad I looked. That's gross. This is probably the single largest, dirtiest board yet. So let's just get this wet down, yes. Isopropyl alcohol, the patron saint of circuit boards.
I don't know if this board had more gunk than usual on it, but after the first scrub, there was still some sort of a sticky kind of residue on it, so I went back and gave it a second round.
I would say that's better. Sticky still, so I'm going to do another run. But that's going in the right direction. Ugh. Okay. I'm going to call that improved. Same questions apply about this. I don't know if that's separation or those are underneath traces. I'm not sure what's going on there. Some of the boards, the larger PCBs seem to have this, so I don't know. Top side looks decent. There are a couple of bits here around the ICs where there's some flux. So I'm debating, I could try to clean those up, but it might just make a big mess. So maybe I'll try one here and see how it goes. First glance suggests that most of these
maybe 10 microfarads, 25 volts, which is nice, because then we can, makes it a little easier to just know, once we read the ESR, okay, I found one different one, 50 volts, 1 microfarad, and I think that one measured 1.8 ohms ESR, which I believe is totally fine, but I can double check that. Yeah, the max is 4.5, so 0.8 or whatever I actually hit there is just fine. All the caps that I've measured here are within ESR acceptable range. Nothing looks toasty, so I think this board's going to be safe to use, which is awesome, at least from a capacitor standpoint. I think I forgot to record all of this, but I just put the 3 screws back in place. We've got the clips on here, distributed across the sides. 2 screws here. That's it. Reassembled and looking decently clean as well. I guess it's come to this. The final boss, if you will. Final PCB to be taken out. So this is the voice board, which has the mix out. I think it's called the voice board. This is voice chips anyways, 1 and 2. And I'm going to leave this connected. I'm going to leave this connected just to be safe. Connected to here. Less confusion that way. Lots of caps. Sure they're fine. 2 screws, bracket, 1, 2, 3, 4, 5, 6, at least on this one, and then there's also the memory expansion, which is a little separate piece to come out. That's an easy one. Oh, that was easy. Piece of cake. So in theory, there it is. And let's see what surprises this has for me. I'm going to assume the underneath is going to be real clean or real gross. Oh, and it's terrible. Good Lord, what happened there? Wow. Well, that is disgusting. Oh, man. Well, I hope that's okay. Well, Vanessa Williams would be very disappointed because that's the last board. Saved the worst for last. It is absolutely disgusting. I mean, the upside is I know what to do. And this should clean up nicely, but good Lord, what a mess. There's some sort of other deposited stuff here. And something ran down them, maybe. Looks foul. And the tape seems to have a certain amount of stuff on it too. Now, that may have been, well, no, that's there. That's always been there, I guess. Maybe that came loose. Water ran. I don't know. This is like doing archaeology on a PCB. Definitely not my forte. Best thing I can do is just try to clean all this up. This one's going to take some work. Gonna need a bigger boat. Gonna try starting from the top and we'll go down here. So, yeah, this was the biggest and dirtiest board, but it was also nice to clean it up, and it took some time. What I find tends to work with these things is, and I learned this later on, if you tilt the board, I think it helps with the sort of runoff as the IPA kind of drips down the board and takes the other stuff, this sediment, with it. And it might help to use a bit more of an aggressive brush to sweep the stuff down, or compressed air to help blow it down and off quickly before the IPA dries off. In any event, I feel like I got this one pretty good. There's sometimes some little brown kind of stains where there's some stuff left, but by and large, it's still much better than when I started. I'd say that's pretty nice. All right. Now for the top side. When it came to cleaning the tops of the boards, I basically just dipped the brush in IPA and then tried to do my best, also trying to be careful about not bending pins and legs and such. Same thing as before, better than before. Could it be improved? Sure. Okay, so this feels like a milestone worth noting. I have now removed every PCB from this thing, minus one little portion of the power supply. So this whole machine has been quite well disassembled, and every PCB cleaned reasonably well to the relative best of my abilities. So I'm giving this the best I can in terms of a shot at a renewed life. And my hope is that I'll be able to reassemble this thing and put in a new LCD here. And the best case will be it lights up and it shows something on the display. That would be amazing. That's what I'm hoping for. Wish me luck. You know, there are times when the natural lighting in my living room looks pretty good. Here's an example. Ugh. Yuck. Don't love that. Looking pretty good overall. A few dirty spots still, but it's not the end of the world. So, next thing, plenty of capacitors to check. So, just to be thorough, I think I am going to go through and check most, if not all of these. Better safe than sorry. Something interesting about this board I want to point out. Only a few capacitors on this one actually have little vents per se. So if and when the capacitor were to fail, that is blow up or vent, you can see these have little scores in the top, kind of for safety. So these I think are 6.3 volts and looks like 330 microfarads. And as far as I recall, these are the only capacitors on the whole machine that are slightly larger and then have these, I don't know if they're called vent holes or vents in them. And the vast majority of everything else are 25 volts, 10 microfarads. And there's a single, there may be a few of them, but here's one of the other standouts. A 50 volt, 1 microfarad. Just a few of those. 0.35, well, 3.36 ohms. Plenty low. Okay, I've tested all of these caps along this row, and they all look fine. So all these caps are in the 1 point something ohms ESR, which means they're good. And those are all, oops, nice, 25 volts, 10 microfarads. As far as I can tell, all these caps are also good. So I have all 4 big PCBs out, cleaned up nicely. Both sides, all capacitors tested at least quickly with an ESR meter, and I think they all look good. So one other bit I want to take a look at is the RAM. Memory expansion module, I should say. That just the usual flux that can be removed on there, and the rest looks clean. That is 768 kilobytes of performance improving memory back in 1988. This was a big deal. Last thing I did remove and do a quick clean on here was this little PCB with a fuse that is between the wall power supply and the transformer. I didn't take the transformer out. I didn't feel it was necessary, and I didn't want to mess with it. So initially I wanted to replace this soldered in place button cell battery with another button cell battery. But once I got this unsoldered, I realized that it wasn't necessarily going to work. This stuff was really stuck on the battery, so I ended up going to use 2 AA's in a little container and then wiring that up to the PCB. The problem I ran into was once I tried to remove the solder and then solder some breadboard type wires back in place, they just wouldn't hold. So I'm not sure if I missed something or that was due to the hole in the PCB. I ended up using traditional braided wire to the battery holder, and that held fine. So I'm sticking with that for now. Ain't pretty, but hopefully it works. I know removing PCBs can be a little bit dry, so coming up next, hopefully will be a little more exciting. I'm able to swap the LCD, connect the new LCD, and then reassemble the machine and see it start to come to life. Okay, I just plugged this in backwards and it's working. I can't believe it. Yes. What the hell? I don't understand. Unbelievable. Watch this. Yes, it works.